Question 8. Give the oxidation state of nitrogen in the following species. So in NO2 minus. Well, I know an oxygen's in group 6, so it forms O2 minus ions. Oxidation state -2. So I've got 2 minus 2's is -4, and I've got a -1 left over. So the nitrogen must be in +3. +3, -2 leaves 1 minus left over. No charge over on the right hand side, so a nitrogen must balance with an oxygen. Oxygen -2 oxidation state, +2 for the nitrogen. So +3 and +2. Write a half equation for the conversion of NO2 minus in an acidic solution into NO. So NO2 minus, acid always provides H plus to make NO. My one problem is that where's the H gone here? So acid solution is H plus, and now I make NO, but where's this gone? Well, H's must combine with some O's to make some H2O. That's the only place the H's and the O's can go. You'll find that in half equations that involve electrons, by the way, then you can add H pluses and waters wherever you want to make H's and O's balance. So H pluses and H2O's are always available to you when you're balancing half equations, that is, equations that have electrons in them. So I've put the water in there. Now I've got 2 H's, so I need 2 H pluses. Let's add up the number of pluses and minuses and put an electron in. If it's half equation, you've got to have electrons in on one side or another. I've got 1 minus, 2 1 pluses, so that's 1 plus on the left hand side. No plus or minuses on the right hand side, so I need 1 minus on the left hand side, so that 1 minus and 1 minus is 2 minus to cancel out the 2 plus. Write an equation for the conversion of I minus into I2. Again, it's a half equation. So I minus going to I2. I'm going to need 2 I minuses to balance up the I2. And I've got 2 minuses on the left hand side, none on the right hand side. So I've got to put 2 electrons on the right hand side. Write an overall ionic equation for the reaction of them both. Well, in this half equation here, you should always have electrons on the left. So oxidation is loss, reduction is gain. So this is gaining electrons. This is a reduction equation. This is losing electrons, so this is an oxidation half, so we've got a redox going on. But anyway, more importantly, to balance it, I've got 1 electron on the left-hand side of this, and I've got 2 electrons on the right-hand side of this. So when I add everything from the left of both equations and put it on the left of my overall, and everything on the right of both equations to add everything on the right of overall, I want the electrons to cancel, and they're not going to, so I'm going to have to multiply this by 2, everything by 2. So 2 NO2 minuses, 2 times 2 is 4 H pluses, 2 E minuses, 2 NO2s and 2 H2Os. Now I've got 2 electrons on the left hand side of this equation here, and I have 2 electrons on the right hand side already on this equation here. So when I add everything on the left, 2 NO2, 4 H plus 2 electrons plus 2 I minuses, and then everything on the right, 2 NO2s plus 2 H2Os plus I2 plus 2 E minuses. My electrons cancel out on each side. They have 2 NO2 minus 4 H plus 2 I minus 2 NO and 2 H2O plus I2. What is the role of NO2 minus in a reaction with I minus? So NO2 minus, we've said it's in oxidation state +3 to start off with, and it forms NO in the at the end of the equation. So I'm turning NO2 minus into NO, so it's going from oxidation state +3 down to +2. So if it's going down an oxidation state, it's reduced. So it must be, if it itself is reduced, something else must be oxidized. It's an oxidizing agent. It actually oxidizes I minus in a -1 oxidation state up to I2, which is 0 oxidation state. In this equation, then I've got 2 ClO3 minus and 5 NO2 minus and 2 H plus, making Cl2, 5 NO3 minus and H2O. A 25 centimeter cube sample of the sodium nitrate, which is this one here, NO2 minus, required 27.4 centimeters cubed of a 0.02 mole per decimeter cubed solution of potassium chlorate 5. This is potassium chlorate 5 with the Cl in oxidation state 5. Let's just check that. So I've got 3 2 minuses for my oxygens in group 6, gaining 2 electrons each, so they're 2 minuses. 3 minus 2 is a -6. plus Cl must be in plus 5 because plus 5 minus 6 leaves 1 minus left over. So this has come from the potassium chlorate 5. For a complete reaction, calculate the concentration in grams per decimeter cube of the sodium nitrite, that's this one here, the NO2 minus in the sample. Well, first of all, I've got a volume and I've got a concentration of the potassium chlorate 5, which is this ClO3 minus. If I've got a volume and a concentration, it must want me to work out moles. So volume is not going to be in centimeter cubed, it's got to be in decimeter cubed. So to get a small unit value up into a bigger unit value, then I've got to divide by 1000, 0.0274 decimeter cubed. Concentration is 0.02. Concentration is moles divided by volume, so 0.02 is moles divided by 0.0274. Multiply the two together, so the number of moles is 0.00548 moles of this potassium chlorate here. Calculate the concentration of sodium nitrite in the sample. So the sodium nitrite is this NO2 minus. Sodium nitrite makes NO2 minus, and I know that 2 moles of this potassium chlorate 5 react with 5 moles of the nitrite and 2 moles of the acid to make 1 mole of chlorine, 5 moles of nitrate ions and 1 mole of water. So the numbers in front tell you the mole ratios. So 2 moles of the potassium chlorate react with 5 moles of the sodium nitrate. 1 mole would react with 2.5. I've actually only got 0.00548 moles of the potassium chlorate 5. I've not got 1. So if 1 makes 2.5 of the sodium nitrate, 0.00548 of potassium chlorate must react with 0.00548 times by 2.5 because it's in a 2 to 5 ratio. 0.00137 moles of sodium nitrite are getting used up. So now it's asking for the concentration. So I know how much sodium nitrate is in there now. During this complete reaction, that's 0.00137 moles of sodium nitrite. So the volume of sodium nitrite is 25 centimeter cubed. It tells me that 25 centimeter cubed. 25 centimeter cubed in decimeter cubed, divide by 1000 to get a small unit value up into a larger one, 0.025. Concentration is moles divided by volume. I've got the number of moles, I've got the volume. Now I've got concentration 0.0548. I've put it to 3 significant figures because the other values seem to be to 3 significant figures. Mostly I've got 4 significant figures there. I've got 3 significant figures. So I'm going to go with 3 significant figures. 0.0548